Fifth grade lesson 3.2 is place value of decimals.
Our essential question is, how do you read, write, and represent decimals through the thousandths place? We've already looked at the tenths place and the hundredths place. We're just adding on to that through the thousandths place. Let's unlock the problem. The Brooklyn Battery Tunnel in New York City is 1 726 miles long. It is the longest underwater tunnel for vehicles in the United States. To understand this distance, you need to understand the place value of each digit in 1 726 thousandths. You can use a place value chart to understand decimals. Whole numbers are to the left of the decimals, so here is our whole number, 1 full mile. Everything afterwards is not quite full. It's an in-betweener, right? So it's 1 and some more. Whole numbers are to the left of the decimal point. Decimals are to the right of the decimal point. They're not quite one whole. The thousandths place is to the right of the hundredths place. So this is the tenths place. That is the hundredths place. That is the thousandths place. Again, tenths place is like dimes. 7 dimes, 70 cents. Not quite a dollar. Almost. 2 in the hundredths place. Hundredths is like pennies. You need 100 of them to make a full dollar, right? And then now 6 is the thousandths place. We don't have a coin for that, so that one's harder to grasp, but it's getting smaller and smaller, right? A dime is more than a penny, and a penny is more than whatever this is. So refreshing our memory here, here's our decimal. So I'm going to even make that bolder, a bolder line there, to let my brain really see that boundary between a whole amount and the in-between amount, fraction, decimal sections, where we're kind of in between this whole number and the next whole number. We have the tens place, right? We have the ones place, $1 bills, the tens place, and then of course you're aware the hundreds place, thousands, 10,000s, 100,000s. We worked on those for a while. We spent a lot of time last year working on our whole values, and now we're taking some time this year to really look at those in-betweens with fractions and decimals. 2 different ways to show these in-betweener numbers. 7 tenths, that's 7 times 1/10, or 7 dimes. It is written as a decimal as 0.7. 2 hundredths is 2 times 1/100th. 2 100ths is written as 0.02, 2 100ths, or 2 hundredths. And then 6 thousandths is 6 times 1/1000th, and we write that as 6 thousandths. That is 0.006. Tiny amount, very tiny amount. We would need 1,000 of 1/1000th means we need 1,000 of these, whatever they would be, coin-wise, to make a dollar. So it's a tiny amount. And just kind of keep in mind, the further we take our value this direction in our decimal side, the tinier and tinier and tinier we're talking about. So a dime is much smaller than a dollar, 10 times smaller than a dollar. And a penny is 10 times smaller than the dime. So the thousandths is 10 times smaller than the penny, and the next place value over is 10 times smaller than even this tiny one. So it gets tinier and tinier. The place value of the digit 6 in 1 726 thousandths is the thousandths place. The value of 6 in 1 726 thousandths is 6 times 1/1000th, or 6 thousandths, 0.006, 6 ending in the thousandths place. So our standard form is 1.726. Word form is 1 and, the decimal is the and, 1 and 726, ending in the thousandths place. So we say thousandths, 1 and 726 thousandths. In expanded form, we have 1 times 1 to give us the 1, plus 7 times 1/10, plus 2 times 1/100th, plus 6 times 1/1000th. So that's how you would write that in expanded form if you needed to. We're going to try that. We're going to use the place value to read and write the decimals. In standard form, we have 2. Remember that decimal is and. This number is 35, and it ends in which place value? In the hundredths place. So we're going to say 2 and 35 hundredths. So there it is there, 35 hundredths, 2 and 35 hundredths, 2 and 35 hundredths. What about in expanded form? Well, I have this 2 represented by 2 times 1. 2 times 1 is 2, plus 3 is in the tenths place, so I'm going to put 3 times 1/10 because it's in the tenths place, plus 5 that's in the hundredths place, which is 5 times 1/100th. And that's how you do the expanded form. Okay, they're going to give us the word form this time, and we need to do standard form and expanded form. So let's do that. Word form is 3 and 614 thousandths. Well, we have this 3 is the whole number and the and. So we have the 3 and the decimal. 3 and. Now I have 614. 614. And then make sure it ends in the thousandths place, and it does. Tenths, hundredths, thousandths. So it has to end in the thousandths place. 3 and 614 thousandths is written like that in standard form. What about expanded form? Well, we're going to do 3 times 1. Oops, let's do it with a pen. 3 times 1 gives me the 3 here, plus we have 6 times 1/10, because that's 6 in the tenths place. I have 1 in the hundredths place, so I'll do 1 times 1/100th. Now that you see it, it doesn't look as complex, hopefully. And then I have 4 in the thousandths place, so I will do 4 times 1/1000th. Oops, that's not right. Let me fix. Okay, 1/1000th. Let's take a look at the example. We're going to use the place value chart. A common garden spider spins a web with its silk that is about 0.003, that is 3 in the thousandths place, so we would say that as 3,000ths millimeters thick. A commonly used sewing thread is about, that's 3 in the tenths place, so we would say 3/10ths millimeters thick. How does the thickness of the spider silk and the thread compare? We're going to write both of these numbers in the place value chart. We have 3,000ths and we have 3/10ths. All right, I have 0 at the front of both of them. And I have, for the thread of the spider, 3,000ths. I need to push that 3 all the way to the thousandths place. And in order to push it over, I used zeros to sneak it on over to the end there. A sewing thread is 3/10ths. 3/10ths. I could put zeros there. It doesn't matter. They're not sandwiched in by any other number, so I can drop them off of there too. It's the same idea as if I say I have $2 and 0 cents, or I say I have $2 and 0 cents. It's still $2, or $2 and 0 cents. Same idea. It's not sandwiched in by any other number like a 1 or something, where now those zeros become important. So the same thing. If I don't have any other number here or beyond it that make that number suddenly become, that place value suddenly become important, like this one is here. This has this 3 sandwiching them in between the decimal. So they're placeholders. I don't really need placeholders over here. I can leave it empty. I can put the zeros, whatever I want. Count the number of decimal place value positions to the digit 3 in 0 and 3/10ths and 3,000ths. 3/10ths has how many fewer decimal places than 300ths? It has 2 fewer decimal places, right? 1, 2 fewer decimal places. 2 fewer decimal places is 10, right? Every move over, we're doing 10, a jump of 10, 10 more, 10 more, 10 more. So that's 10 times 10 for the 2. So it is 100 times different. So 3/10ths is 100 times as much as 3,000ths, and 3,000ths is 1/100th of, meaning it's going the opposite direction, smaller. So that is how you would word that. So the thread is 100 times as thick as the garden spider's silk, and the thickness of the garden spider's silk is 1/100th that of the thread. I hope that made sense to you, okay? And let's take a look at the try this, because we can use place value patterns to rename a decimal. It can be called by a couple different names, and that's okay, and still mean the same thing. So we'll use these place value patterns. Let's rename 3/10ths using other place values. I have 3/10ths, 3 in the tenths place, 3 times 1/10. What if I put this 0 on the end? I can call that 30/100ths. It's still the same though, right? Remember I was talking about sandwiched in. 3/10ths and 30/100ths are the same thing. 3 dimes and 30 pennies, same thing, right? 30 cents. So that's kind of the relationship that will help you make sense of that. 300 thousandths. I'm just going to put thousandths, because I don't have enough room there. And that is 300 times 1/1000th. So we can call these all by the same, by different names, as long as it's a matching amount. 3 dimes, 3 in the 10th place, is still giving us 30 cents. And 30 pennies, 30 in the 100th place, is still giving us 30 cents. And if we had such a coin that broke our dollars into 1,000 pieces, 300 thousandths would still be 30 cents. So that's how that's working out. All right, let's look at the share and show. They want us to complete the place value chart to find the value of each digit. We have 3 and 524 thousandths. It ends in the thousandths place, so 3 and 524 thousandths. This is 3 times 1 to give me 3. 5 in the tenths place is 5 times 1/10 in expanded form. 2 in the hundredths place is 2 times 1/100th. And 4 in the thousandths place is 4 times 1/1000th. Okay, what does it look like as a decimal? Well, this 3 looks like a 3. We have the 5 tenths. We have the 2 hundredths as a decimal, like that, 2 hundredths. And as the thousandths, that 4 is a 4 ending in the thousandths place. That's how you work that through. And when you put it together, 3 and 524 thousandths. Write the value of the underlined digit. This is 4 in the hundredths place. So 4 times 1/100th in the hundredths place. 4 hundredths is how we could write it as well. Remember that thus at the end when we're dealing with anything on that side of the decimal, it's the thus at the end. All right, we have 6 and 234 thousandths because it ends in the thousandths place. What place value is this? This is the tenths place. So we have 2 times 1/10 or 2 tenths. How about here? We have 3 and 954 thousandths because this ends in the thousandths place. What place value is the 4 in? It is in the thousandths place. So that's 4 times 1/1000th or 4 thousandths. All right, and here they want us to write the number in 2 other forms. We have 253 ending in the thousandths place. So as a word form, I would write 253 thousandths. And in expanded form, so that's all together there, in expanded form, I would put 2 in the tenths place plus 5 from here in the hundredths place plus 3 in the thousandths place. And there's my expanded form. All right, go ahead and try this one. Pause and try this one. We're doing the same thing. Let's see how you do. Push play when you're ready. All right, I have 7 and 632 ending in the thousandths place. So I would read that as 7 and 632 thousandths. 7 and 632 thousandths. I'm just going to put thousandths. And then I can do that in expanded form like I did here. The whole number is just going to be 7 times 1 because that's 7. 7 times the ones place, right? And, or added to, 6 in the tenths place plus 3 in the hundredths place, and finally plus 2 in the thousandths place. And there it is. This is what the lesson's going to be asking you to practice. So hopefully that was enough information to help you be successful on Think Central. Good luck.